Hello again from Dr. Kate. I'd like to spend a little bit of time talking with you about what we call the philosophy of science. Some things that are important to take note of are some concepts. One area of distinction are necessary versus sufficient variables. If something is called a sufficient variable, that means it leads to some kind of a change or impact on a dependent variable. So when we say something's sufficient, that also means that there are other variables that also relate to having some kind of an impact on a dependent variable. Now, if we could identify a necessary variable, that means that that variable has to be there. It has to be present in order for something to happen, like a change in attitude, belief, or behavior with a dependent variable. Now, like I'll be mentioning multiple times, we in the social sciences have taken concepts that are really from the hard sciences and you're trying to tweak them in a sense to make them fit the social science world. If a variable could be found to be necessary and sufficient, or sufficient and necessary, that would mean we could, in social science, identify one variable, one independent variable, an IV, that would then, if it's present, link to a change in attitudes, beliefs, or behaviors in a dependent variable. The likelihood of this happening is infinitesimal. I don't think it's really possible. And so let's talk about this for just a moment. How can this be? Well, let's say we want to understand why adolescent boys engage in violent behavior. And we'll even talk about video games being linked to their use, violent behavior. Can we say that an adolescent boy playing a violent video game in and of itself is going to lead to violent behavior? The answer is no. That isn't both necessary and or sufficient for there to be violent behavior exhibited, because there are plenty of adolescent boys who play violent video games that don't exhibit violent behavior. And if there are adolescent boys who both play video games and also exhibit violent behavior, there are many other variables associated with that. You can't just say it's one thing. And next, I'd like to just briefly touch on laws in communication, which you can see is in quotes, because just like the necessary versus sufficient explanation I was giving you, laws are another thing that the social sciences, like communication, try to, in a sense, copy what is done in the hard sciences. So when you think about laws in the hard or natural sciences, there might be a few that you can think of. If you want to pause at this point and try to come up with some without me spouting it, feel free to do so. So laws in natural sciences. The law of gravity, you probably at least have a bit of familiarity with. So what is the law? As something goes up, it must come down. The Einstein's law of relativity, that would be another example of a law. So what can we do in the social sciences that we could say are laws? What must happen? Well, the truth is, if we could identify laws in our discipline, that would mean communication as a field is in a deterministic state, which would mean that we could predict, like perfectly predict, what could happen. What we really are at in our research is description, meaning we can describe what's happening. We're going to talk about description of a phenomenon, meaning something that's happening in the world. Well, we can certainly do that, and we do as researchers, do purely descriptive research. We also have theoretical research. If you've already taken a comm theory course, you've been exposed to multiple types of theories that we use in our field. Theory is useful to explain what is happening. It's also useful to be able to predict what you think is going to happen based upon what the theory says are the variables that fit together. But we aren't in a state of control, which is what we mean by a deterministic state. In fact, to me, the only law I can think of in communication is that you cannot not communicate. You cannot not communicate. So in a given situation, let's say a dyad between two people, even if you're not saying anything, you're communicating. So when people say, they're not going to say a word, their nonverbals are communicating. So to me, I guess that could be a law. I don't know how useful it is. Not like the, law of gravity, but I can't really think of any others. If you can, let me know. So when we're trying to come up with a study, here are some things that we need to consider. The first thing is that we have to have a focused, narrow topic. I can't just say, I want to study violence or even violence in the media. That's a huge field. And we're going to talk about searching for literature. So just think right off the bat, you need to have a focused, narrow, specific topic. So who is it that you want to study? About what? And what kind of an outcome? That's what we mean by narrowing a topic area down. Can you actually pull off the study? So, this might mean, do you have the resources financially to do so? Which is also, you can see on the right-hand side of the column. But, can you really even get at the population that you would need to study? It can be difficult to study protected populations like minor children. You need to get permission from a school board, from the parents, teachers, and so on in order to do so. So can you even do what you propose to do? Yeah, I'll be talking about studying injection drug users, which is a difficult population. So working with folks at the AIDS Resource Center of Wisconsin helped to make it possible for me to get to that population to do some research, which I'll go into at a later date. Can you analyze the data? Well, you can be trained in that, certainly. Depending on what kind of data you're trying to collect. Do you have it within your arsenal to be able to do the analysis necessary? Or do you need to bring other people on board? Which is also typically the case in larger studies. Yeah, I've been involved with multiple grants where I'm just brought on for a particular reason. I'll be paid for my time to do certain things, to assist with a grant-driven study. Is what you're trying to study, it doesn't matter. What is the significance? We usually talk about social significance in our field. Does it really matter? And to us, that's kind of an important factor. And not to mention, is it generalizable? So if I want to study whitewater students, does that really matter beyond the university? So I'm interested in doing a study this semester with students who use the Whitewater Food Pantry. Okay, that's fine, but will that benefit others? And I would argue it does, because what I will uncover through this data gathering and analysis could very well be important to other universities who have food pantries. Resources, we're typically talking about money here. So for the students that I want to have be part of a focus group, I would have to give them some sort of a payment for their time. So for that purpose, I contacted the university bookstore to see if they would donate some certificates that I could use in order to give those to students participating. And I think that'll be successful, which is a good thing, because I really, don't have any other funding in order to just pull this out, and other than my own pocketbook to pay for this. So, ideally that you don't have to go about as a researcher draining your own personal funds. So you look for other ways to do so. Is what you propose to do something that is doable? So I can't really do an experiment with students with the Whitewater Food Pantry. I can't say, well, I'm going to have one group that when they go in, there aren't going to be any healthy choices available versus another group that's going to have some healthy food as well as processed foods and other less healthy options, and see which foods they pick. That really wouldn't be doable or really ethical, which relates to the last point about not harming your subjects. That's one of the first things when you are a researcher that you have to not only understand, but kind of live by, that you do no harm. And you have to go through a process that we'll talk about where a review board has to actually look at what your plan is and approve it. And that's one of the major considerations, that what you're doing isn't potentially going to cause harm to whoever it is you plan to study. There's a distinction between academic research and private research. Academic research is often basic research. We are doing research for research's sake. We have a research question in mind and we want to pursue an answer. And that's, folks like myself are doing that style of research. Versus in the private sector, it is much more practical, I guess you could say, is what we mean by applied. So NGOs, which are non-governmental organizations, they might be interested, this would be like nonprofits, they might want to do a research study that would be very specific about how they could improve their services to their clients. So that's a very applied reason to do a project. Consulting firms that aren't through institutions like universities also can definitely be hired and are in the business of doing very focused, applied research. So strengths and weaknesses of this, and they are very different. I think a strength of the applied world is that you can get things done much more quickly. You don't have as many hoops to jump through. If you're not going to go through the institutional review board, which is part of academic research. Academic research tackles relatively small issues and tries to build a field of study, a body of knowledge, we call it. In the applied world, you're trying to solve problems. So if you think about those differences, which are definitely major, you can see where maybe applied research can make a big difference with a very small group, like clients of a nonprofit organization, whereas our goal in the academic world is to make a difference within larger contexts. So basic versus applied. Where do we, as researchers, and really I suppose beyond that, get our information? Well, for us, number one, we turn to the academic journals because those are called peer-reviewed, meaning other folks in their field, other academics have looked at it, have critiqued it, have probably suggested it be revised in certain ways before it will get published. So depending on the journal, there's more rigor or not to getting published, but regardless, there's at least some review process, as opposed to reading trade magazines, popular press magazines, searching around via Mr. Google on the internet or other kinds of sources in that way, like Wikipedia, which is relatively useless, except that you can find within Wikipedia often hyperlinks that could take you to the actual research. The same with the trade pubs and magazines. They themselves aren't the sources we want. What we want are the original pieces of data, which is the studies you'd find in the academic journals. Archival data is something I'll talk about more when I talk about meta-analysis, where we're pooling together sources of information. So I'll leave it at that for now. So this leads to the scientific method that I've been talking about. What do we do as researchers? We tend to focus in a particular area of study, and we can do our research in multiple steps, sometimes through your entire professional career, trying to show a field what you can contribute to it. And you show them through your studies that then are presented and published. The scientific method is meant to use objective measures and means to gather data. The way that you gather the data is such that other people, when you explain it to them, would be able to do the same type of study. You're going to go through a process, and we'll talk about some of those processes coming up soon. Being able to reproduce the study is what I'm talking about, being clear in your explanation of what you've done so that when others read your work and if they wanted to do something similar, they could. One study, one researcher or researchers' findings isn't enough. That's why there are often multiple studies done by different researchers seeing what they find. And that's what we mean by iterative. We're going to do multiple studies and see if we get consistency with the results in order to advance the body of knowledge in a field. So, researchers try, if you're hard or social science, to explain what's going on, predict what's going on, and ultimately to control what's happening. But like I just said a little bit earlier, we are not in that deterministic state in the social sciences. We can explain, describe what's happening. We can use theory and make predictions, but we really aren't in a control situation, although that is the goal. Like I mentioned just a bit ago, we try to find laws, just like the hard sciences do. Will we ever find them in a true meaning of that word? I don't know. But I do know the goal of science is to have a deterministic world where we can accurately explain, predict, and control what's happening. So as I mentioned a couple times, descriptive research is just telling through observation what's going on. Explanatory is where you're trying to use theory and give a why to what's happening. So it's not just what is occurring, but why is it occurring? And that's through theory application, where you're applying particular variables that are part of that theory in order to explain what happened. Basic research, often used in the physical sciences, is doing a study because you're curious. So in the hard sciences, what this would be like doing bench research in a laboratory, where you're going to do different versions of mixing chemicals together to see what kind of reaction you get. That's basic research in the hard sciences. And as I mentioned, the applied research, which is much more in the social sciences, what we do, not that they don't, of course, in the hard sciences, but we're trying to make an impact within certain fields, like nonprofit organizations that serve the needs of folks living with mental illness. That would be applied research. Research is never set in stone. Those results are only for now. So I would call them tentative because something someday is going to come along and it won't fit what we think we know now. Happens all the time. You just think about things you've heard as far as, new study shows that, eating a certain kind of food increases your risk for a certain kind of disease. That's the type of thing we mean by tentative. You probably don't remember, but there was a time that we weren't supposed to eat peanut butter, that researchers had found that it had links to cancer. So eating a certain amount of peanut butter was bad for you. We've had that same kind of an argument with eggs. How many eggs you should eat in a day and or week, and if you should eat the yolks or don't eat the yolks. And the research has flip-flopped and changed on that, even just in my time on Earth. So we accept that the findings that we have can be changed. That's what we mean by modifiable. And if we get new evidence, then how do we incorporate that into what we thought we knew? Null hypothesis is a really critical term for you to be aware of, as I'll be referring to it in a lot of ways this coming semester. What we are trying to do in our research world is reject the null hypothesis. The null hypothesis states that there is no relationship between the variables you're studying. The computer, when you're doing quantitative research, is going to test the null hypothesis. If the computer determines that there is no support for the null hypothesis of no relationship, that means that the researcher, what they have predicted, may be statistically supported. The computer doesn't know or care what it's testing. The computer doesn't have any stake in the game, but the researcher does. And the researcher is asking the computer to test the null of no relationship, which, if it can be rejected, means something is going on between the variables that the researcher is studying. We're going to talk about methods multiple times. Methods matter. The methodology you choose to do a research study has an impact on what you're going to find. And we're going to start talking about that when we begin with the experimental design. You have to, as a critical consumer, which I hope you will become, you have to be aware of what kind of study was used. What kind of methodology did a study employ? Using a survey method versus using an experimental design will matter as far as how likely it is you will find a significant result. And those are the kind of things that we're going to take a look at. The methods or methodology section of a research article is really the part we're honing in on, zooming in on this semester. What did they say they did? How did they do it? And what do we think about what they did in a critical fashion? So, talking again about the types of research and what one might find. If you were doing some kind of a study related to a health campaign and you used an experimental method or design, it is often the case that you will see in your results that the type of mediated messages that were created for the health campaign mattered, influenced significantly an audience that saw those messages. However, if you use a survey method, it may be that you would not find that the audience was influenced by seeing, hearing, viewing some kind of mediated health message. Why? Because the methodology matters. And these are critical things for us to pick up on as we move forward. So what are some differences between methodologies? The number of people involved in a study. You can run an experiment with relatively few people, surprisingly few, as we'll talk about. You could do a survey of hundreds, thousands, tens of thousands of individuals. Homogeneous versus heterogeneous. Homogeneous means that your population is similar. Heterogeneity, or having a heterogeneous population of participants in your study, means that you would have people from very different walks of life. If your participants are like each other versus if your participants are dissimilar to each other is going to matter to what it is that you find in your results. How much control you as the researcher can put over a study matters. We're going to start with the most tightly controlled, which is the experimental design, shortly. This leads to what are people looking at or not looking at in a given study. The more control you have over that, the more likely it is you're going to be able to achieve a significant finding. When you ask people about what they viewed, if you ask them immediately, as soon as they see something, versus asking them 1 day later, 1 week later, a month later, and so on, that's going to matter because methodology matters. How important a topic is for your study participants also is going to come into play. If you're doing a research study on something that has personal interest to them or has a personal meaning, like you're doing a health campaign study and the person or people that you're studying have that health condition, well, how much they already know about the topic and how personally involved they are with the topic are going to be, very different than if you're just doing random sampling of people, most of which probably have no connection with the topic. So, wrapping up here, what are we doing? First, you're doing the research questions, which is why I asked you to write pairs of questions that share one variable. Once you are successful with that, we formulate hypotheses. Hypotheses are really the prediction. First, you ask the question, what is the relationship between the independent variable and dependent variable? Then you make that prediction. So if the question is, what's the relationship between the class rank of college students and their involvement in professional organizations on campus? The hypothesis could be the higher a college student's class rank, the more likely the student would be involved in professional campus organizations. That's the prediction. And your prediction needs to be specific. Your research question is general. The hypothesis is going to identify the value of your independent variable and also what do you think is going to happen. Now I just gave you an example of an assignment and ignore that due date because really what's important here is that once you get all of your research questions, you get a 10 out of 10 on that, you turn to writing just 5 predictions or hypotheses. And that's that.